Hello everyone. I'm Dr. Sneha Pokharkar. Once again, welcome you all in the lecture series of data management and analytics. In previous sessions, we have already started our discussion with the entity relationship model and we understood many concepts related to that. Today, we are going to discuss about mapping cardinally constraints. So, we already know that we can express the number of entities to with another entities, and these entities can be associated with each other by a relationship set. And most useful relationship set used is a binary relationship sets. For a binary relationship set, the mapping cardinally must be one of the following types. And the types are either it can be one to one, or it can be one to many, or many to one, or many to many. These things, how they are going to relate it with each other is it will decide the ER diagram, final ER diagram of our system. So here are some examples. If now from A and B, these are the two entities, and out from this, some elements like A1 is related with the B1, A2 is related with the B2, A3 is related with the B3. So if this relation is one to one, the kind of mapping is known as one to one. Now let's take another example. Here, in this entity, A1 is related with B1 and B2 both. A2 is related with the B3 and B4 both. And A3 is related with the B5. So this type of relation is known as one to many. Correct? And it is not necessary each and every element should be connected. Some of the element may be mapped with other elements. Next, now like previous, this A1 and A2 are related with the B1. A3 is related with B2 and A4 and A5 are mapped with B3. So this mapping is, if you consider this as a first entity, so many elements in first entity are mapped with the sum of the elements in B. So this type of mapping is known as many to one mapping. And if both are mapped with the both are mapped with the many elements of each other, like A1 is mapped with B1, also A1 is mapped with B2, B1 is mapped with A1 as well as with the A2, A3 is mapped with B3, and A4 is also mapped with B3. So if this relation in both ways, this type of mapping is known as many to many mapping, right? So these are the four categories. Except this mapping, there are attribute types also, which shows this mapping simple and composite attributes, or it can be single valued and multi-valued attributes. Example of multi-valued attributes are phone numbers. One person can have multiple phone numbers. So this can be treated as multi-valued attribute. Then the next one is derived attribute. So it can be computed from other attributes. For example, in many application forms, we are just filling date of birth and automatically it calculates age. So these are nothing but derived, which are derived from the data provided. Correct? And domain means the set of permitted values for each attribute. Now suppose for a particular thing, if for particular application, if the age limit is between 18 to 35, so it will automatically decides the age between 18 to 35. If your age is 35 years and 1 month or 2 months, it will reject your application submission. Correct? So domain is nothing but the set of permitted values for each attribute. Now let's take example of composite attributes. Name. If you take name, name consists of first name, middle name or last name. So it is a combination of all three basically. If not, maybe it is a combination of first name and last name. So this type of attribute is known as composite attributes, which is made up of the set of different attributes. And these attributes are named as component attributes. First name is a component attribute, middle initial is component attributes, and also the last name. Let's take another example of composite attributes, that is address. Inside the address, there is a city, street, city, state, and postal code. Again, in the street, you can consider street number, street name, and apartment number. So these are nothing but component attributes, and address is nothing but composite attributes. Now, suppose we have entity set like instructor with the attributes ID, name, department name, and salary. Department with attributes like department name, building, and budget. So we model the fact that each instructor has an associated department using a relationship set instructor department. And the attribute department name appears in both the entity sets. If you see here, department name is present here also, and all department name present is here also. Since it is the primary key of the entity set of department, it replicates information present in the relationship and is therefore redundant in the entity set instructors and needs to be removed. Correct? But when converting back to the tables, in some cases the attributes get reintroduced, and that we are going to see in the later part. Now consider a section entity, which is uniquely identified by a course ID, semester year, and section ID. Clearly, section entities are related to the course entities. Suppose we create a relationship set section course between entity set section and course. Note that the information of sectional course is redundant since the section already has an attribute of course ID, which identifies the course with which the section is related. One option to deal with the redundancy is to get rid of the relationship section course. However, by doing so, the relationship between section and course becomes implicit in an attribute which is not desirable. It means many times we cannot avoid redundancy. Redundancy is the need of a particular data set. An alternative way to deal with this redundancy is not to store the attribute name ID in the section entity or to only store the remaining attribute section ID, year, and semester. However, the entity set section that does not have enough attributes to identify a particular section entity uniquely. Although each section entity is distinct, sections for different courses may share the same section ID, year, and semester. To deal with this problem, we treat the relationship section course as a spatial relationship that provides extra information in the case of the course ID required to identify section entity uniquely. The notion of weak entity set formalizes the above intuitions. A weak entity set is one whose existence is dependent on another entity, called as identifying entity. Instead of associating a primary key with the weak entity, we use the identifying entity along with the extra attributes called discriminator to uniquely identify a weak entity. An entity set that is not a weak entity is termed as strong entity set. You may find all these things difficult to understand right now, but in our next lecture, when we will see all the symbols of ER diagram, at that time these things will clear to you. What is weak entity, what is identifying entity, and what is strong entity, right? So every weak entity must be associated with an identifying entity. That is, the weak entity set is said to be extensive dependent on the identifying entity set. The identifying entity set is said to own the weak entity set that is identified. The relationship associated with the weak entity set with the identifying entity set is called as identifying relationship. And note that the relational schema we eventually create from the entity set section does not have attribute course ID for a reason that will become clearly later at the time of drawing the ER diagram. Even at the okay, so now we'll discuss it on the later on, even though we have dropped the attribute course ID from the entity set sections. Okay. This was all about only the relationship mapping, which is one to one, many to one, many to many, and one to many. and also some information about the weak entities. In the next lecture, we are going to see about the symbols used in entity relationship. So many things which are confusing right now will be clear in the later session. Thank you so much.